Okay, guys, so welcome to the first talk is about Backbone.js, and this is the first step of a series of talks and trainings about UI technologies. So this is a program of Avenue Code where we are going to go over the modern technologies that are going to be used on the clients that we are going to work at this year, okay? So the agenda for today, I'm going to talk about JavaScript and the HYPERSPACE. You might be wondering what the hell I'm going to talk about, but it is related. Web architecture, client-side versus server-side, REST, JSON, MVC, web frameworks versus client-side apps, Backbone.js, and under Backbone.js, we're going to cover model, collection, view, and router, and also dynamic templates. Okay? That's what we have for today. First things first. So JavaScript and the HYPERSPACE. What is the HYPERSPACE? So this is a common concept as you watch movies like Star Wars, Star Trek, Hitchhiker's Guide to the Galaxy. HYPERSPACE is one dimension above. So it's one dimension that we cannot understand. If you are in a sheet of paper, it has only 2 dimensions, but there is one extra dimension around with the 3D space. What I'm trying to mean here, we have a dimension surrounding us that helps to control the current dimension. What do I try to mean with this? We can only see up to the current dimension. So let's consider a browser. A browser has 3 dimensions that we can understand. First, a browser was conceived to render hypertext. So you can see the static view of HTML and CSS, which is just display. It's just the same thing as you print out paper, you read something, you do not interact, as the first proposition of a browser, okay? Then it was introduced the concept of DOM, like we can access the DOM and change the DOM, so we can interact with the content. It's not just static content anymore. We can start to interact with this content. So in my understanding, it's another dimension. Third dimension, behavior. We can now interact more and attach events and responses with the user, with the network, with rendering, displaying things. So I would consider this as a third dimension, okay? And the fourth dimension would be the HYPERSPACE. How would it be? So what do you guys think that would help to control behavior, elements, and rendering? Like, as you see, the dimension above helps to control the inner dimension. So if you have JavaScript, it's easier to manipulate the DOM. If you can manipulate the DOM, it's easier to change the rendering. So what would exist to help us to change the behavior, to organize the JavaScript, to organize the way we interact with the code? So let's think about that for a minute. I will go over with the presentation, but that's where I want to get, okay? Right, so let's go deep in web architecture for a moment. So we have the definition, application ends. We have the front end, which is the part of the application that interacts with a human. And we have the back end. It's the part that handles business logic and data access or service access, okay? This is a well-known concept, front end and back end. We also have the application sides. We have the client side is the part of the application that runs on the user browser or the user device. And we have the server side, which is the part of the application that runs on a server. And most of the times we think of them as the same thing. We understand front end as client side and back end as server side and vice versa. But they are not the same thing. Why? That's the purpose of this talk, to understand how they are not the same thing. Because we can have front end to run, front end actually runs on the client side, but we can also have back end running on the client side. You see, so that's the idea that we're going to talk about here. Okay, so client side versus server side. Let's consider 4 kinds of applications to make it easier. isolated web apps. So let's suppose we have applications only in the client side, which means if you have a browser, it's an application that runs completely inside your browser. Or if you have a mobile device, a mobile phone, it's an application that runs on your phone. It does never connect to the network, to any server, okay? Or let's remember about the old times when you have that desktop applications in Java, Swing, do you remember? So, and they didn't talk to the backend, to any server, actually. They had a backend, but they didn't talk to an external server. Okay, you have just a local database or a file, and etc. So that is a client-side only application. In this kind of application, we could have only front end. For instance, BMI calculator. BMI in Brazil is IMC. So it's the calculation of your mass. If you give your height and your mass, it says the rate that says if you are fat or if you are thin, if you are healthy or not. This is very common to find when you do some gym. EMC. So a BMI calculator, if you look in the internet, is very common, and it's just a single mass. It's just one single mass, like you put something in a square, and it only takes one line of JavaScript to do it. So this is only front end. There is no business logic connection to database data services. So I would consider this as a front end only application. It's the same thing as a calculator in your mobile phone. It's just a isolated web app. It doesn't need any backend, any service. Okay, it goes to the processor of the computer to execute this and returns the results. Now, front end and back end. A to-do list manager. So let's suppose, today, if you learn any MVC framework in JavaScript, the first application you're going to see is a to-do list. And it's good, because it will teach you how to work with this framework. But you can have a to-do list manager persisting on the HTML5 local store browser. So HTML5 introduces a way to store content, persist content inside the browser. It's like a database. Like Chrome has a local storage, Firefox has really a database inside, a SQL database, where you can persist information. So using this concept, you don't need to go to a server. You could store things inside. For some cases, it might be enough. Okay. So this kind of app, you have front end and back end in the client side, and you don't need to communicate with any other server. Client side versus server side. So what is this about? We have integrated web apps, and this time I'm talking about a client side and a server side. So let's suppose a client side uses a browser. We could have the classic scenario where front end runs on the client side and back end runs on the server side. This is the classic scenario that we can find in Struts, JSF, Rails, Spring MVC. And in this case, the client side has some request, some form or some navigation. The server side will route. It will delegate this call to some service that will get some data or save some data. It will get an answer from that. It will generate a template. And this template will be HTML, which is going to be delivered to the browser. So in this case, the browser receives the result. Okay? And we transmit hypertext. We transmit HTML over the network. Okay? So now I'm going to introduce you this case. We can have the front end and some kind of backend on the client side, and another backend REST on the server side. So now we are separating, and the backend on server side will only deal with data. It will only get data, work with data, save data, and retrieve data. And in the client side, we're going to have another backend that is able to route the requests and to get the data, put inside a template, render the template, and put into HTML result. In this case, the response is data over HTTP. Then the data that we get from the REST server goes to the front end. not the HTML. The data goes to the front end, and the front end uses this data to generate the result and render automatically on the client. An example, a Trello. Trello is an application, is a task manager, which is implemented in Backbone.js. Okay? So let's understand more about this scenario. REST. What do I mean about REST? What is REST? REST is a representational state transfer. What is this? It's a stateless architectural style for distributed systems. And REST is based on HTTP protocol, and the way the HTTP protocol was designed, REST is going to use all the concepts about the protocol. For instance, the methods of the HTTP, like get, post, put, delete, options. Every HTTP request needs to have a method. Okay, before we just used get and post, but since the beginning, REST has like 8 methods. I think it has more now with HTML5. In this case, we have already the method. So in REST, we decided to use the methods as verbs, as the actions. So I'm going to explain this better later. The URIs is the name of the URL. If you are in the web, is the URL, is the resource name. Those are the nouns. So what are we talking about? So if we call a URL / card, so if you do a get on a URL that has a /card, you are trying to get a card. And you're going to see this more explicitly when I show the examples. Another part, HTTP always has status code. Like 200 is okay, 404 is not found, 500 is internal server error. So in REST, we use those status codes to tell us if the went well. Let's suppose I ask it to save something. If I get 200, it means it was saved. If I get 404, means my resource was not found. If I get 500, there was an error. And there are many other status codes. So let me give some examples. What we're going to talk about today. HTTP GET. Retrieve is a resource. For instance, if I get /users/1, I will retrieve the user which ID is equal 1. So it's telling server, go to your database or whatever and bring me the user ID is equals to 1. Okay? So this is really API. REST is a kind of API. It's an interface for us to program and interact with the services, which are, by the way, web services, once they are over the web. HTTP post. It creates a resource. So if I do post to /users, it will create a user, but I need to pass the data to this user on the request body. We have HTTP put. It will update a resource that exists already. Like if I do put /users/1, it would update the user which ID is equals 1. And I also need to send the data that I want to change inside the request body. HTTP delete. It will remove a resource. If I do delete /users/1, it would remove the user which ID is equals 1. So with those 4 actions, we can do the persistence. I can use get to get 1 or maybe more resources. I can use post to create a resource. I can use put to update a resource. And I can use delete to remove a resource. What is this? This is a CRUD that all those frameworks try to do. So with REST, we have a unified interface for the server to respond to any front end. I could write a JavaScript application using REST to communicate with the server, and there could be a mobile application, an iOS, Android application that can use exactly the same services REST to interact with, and the server would be the same thing. The same implementation could serve different front ends. So this is a standard. And the good thing is that, like Backbone.js, as we're going to talk, many JavaScript MVC frameworks are based on REST. So this is coming to be like a default today. JSON. What is JSON? JavaScript Object Notation. This is a universal format to transfer data in JavaScript. Actually, you transfer data through HTTP, and JavaScript can parse that. Today, any language can parse JSON very easily. So it's easy to, if you want to communicate, for instance, in the system that I work today, in my client, I get from a Java system. The Java system has a REST interface, and I get JSON. And my client side in Backbone.js will just read from this and execute. What's the advantage of JSON? JSON started as an alternative to XML because the XML used in web services, you know, the SOAP web services, they had a very big payload. Like, it's huge. If you look to the structure of the XML, you're going to see lots of tags, lots of attributes, lots of things. It's hard to read, and it's big, and it's all text. That's the problem, because we are designing for the web. The web is not binary. The web is string, is text. So if I pick a huge string to transmit over the internet, it's not a good idea. I better to try to use smaller representations of data. Then they came up with JSON. JSON has a reduced size, simplified format, and it's easy to parse. It's very fast to parse. So this is a good alternative to XML, at least for this scenario, because we are talking, the client is talking to the server. So let's suppose we have a server in the world, and we have clients all around the globe trying to access one server. Let's say e-commerce. So this response should be very small. The smaller the response is, the better. We can serve better, we can have more clients. So that's why people like JSON. Okay? This is just an example. You can specify attributes like names, R2D2. We can specify arrays. This is Anakin, Leia, and Luke, the owners of R2D2. We can specify attributes as another object inside that it can have number like in float format or in integer format. So we can represent basically any data that can be represented with a string. Okay? All right. MVC. It's the other component we need to address. MVC is Model View Controller. What is this? It's an architectural design pattern that leverages better application organization through separation of concerns. What is that? I'm going to organize my application into separate places. The model will care about the business data only. The view will care about the user interface only. And the controller will care about connection and data input logic. Okay? So, if we have separation of concerns, it means that if we change one part, we not necessarily need to change the whole application. Because if we don't separate the concerns, maybe we need to change one thing in the model, and you have to change all the classes, all the files, all the services that you have. So if we do separation of concerns, we can change one part isolated from others. MVC in JavaScript. It's a very good idea. It avoids spaghetti code, which is hard to read and maintain for the lack of structure. It's very common because JavaScript was conceived not to to structure an application. It was conceived just to deal with events and deal with the browser. And then people started to write real applications in JavaScript. But before, in the old times, JavaScript was not used for that. So then people started just to add features, add functionalities, and it started to get huge, hard to read, hard to maintain. So that's why it's very good to start using separation of concerns in JavaScript. The overall maintainability is strongly improved. It makes it clear to identify where to change the code. Like I said, if you have a change in the model, let's suppose your model needs to calculate something from a value, and if you have a model, you can implement inside the model a function just to deal with this data transformation. We need to transform some data that you receive in a model. You can do this operation just inside the model. It has nothing to do with the view. The view just wants to receive data and render, and the controller just needs to connect the parts. So this operation is specific to model. So just the model takes care of that. Okay? It will enable more objective unit tests. Should you want just to test the model, you don't need to worry with the other parts. You are just testing the model. Modularity allows better distribution of tests among the team. So you can have one person working the model and another person working the view, and it might not impact much. So, and this is our hyperspace. That's what I was trying to talk about. It's something that will enable us to organize what we have today, our JavaScript. Okay? So, this is the goal. And how to achieve this goal? How to use this? So, let's do a small comparison between server-side web frameworks versus client-side apps. In server-side web frameworks, the actions lifecycle is managed and routed on the server side, like in struts, Spring MVC, and Rails. You have a router file or class that will receive the routes, send this to controllers that go to services, and after this they send to the view, and the view sends the data to a template that will render to the browser. So this life cycle happens in the server. Okay? Rails, for instance, take care of that. Server-side templates generating HTML from data. HTTP response transmitting hypertext. Every action demands a page reload, unless you use AJAX. But if you think about the page navigation, the navigation of pages, you are reloading every page. You do a HTTP GET from the browser. So the browser will go to the server side, bring HTML, and render in the browser. So it needs a page reload. Actions are synchronous, mandatorily, and the browser will wait for the answer. You do a request, the browser waits. Once the answer comes, it will render. You are blocked if you are waiting for an answer from the server. Even the AJAX is synchronous, if you think like that. The AJAX request is a synchronous thing because you do a request and it will return. But the advantage of using AJAX is that you allow the interface to be used on another thing. So by any time that the response comes, then you can deal with this, you can process, and you don't block your user. But the AJAX call is also synchronous if you look that there is a process that you need to go to the server and return with a response. So that's the idea. If you want to go to see a page, you have to wait for the answer so that you can see this page. Now, client-side apps, how they deal with this. The actions lifecycle would be managed and routed in the client side. So, you click on a link. The JavaScript will intercept the link. It will go to the server just asking data. The server returns with data. And now, the JavaScript will know which view, which template it needs to render and render. So this part moved to the client side. The HTTP response is now transmitting data, JSON, XML, etc. Server-side templates now are generating HTML from data. Actually, I think it's wrong. It's client-side templates. Yeah. Yes. I need to change that. So client-side templates generating HTML from data. Actions don't demand page reload because who is going to receive the response from the server is not the browser handler. It's your JavaScript code. So you can do whatever you want. If you don't want to refresh the page, you just render another template or do anything. Okay? And actions can be asynchronous. In this term, you can go to the server, you will free up the interface, As soon as you receive the response, you process that. Okay? I'm talking about page navigation. Okay. Now I will talk about Backbone.js. So I'm sorry that we are taking more than the normal because we lost some minutes. Okay. So I try to make it quick. And if you have any question, we can talk in the 10 last minutes. Okay. So JavaScript library that provides the structure to client-side applications based on REST APIs using JSON. This is Backbone.js. We have many other MVC frameworks in JavaScript that are built around the same concept. It's just a JavaScript library to give structure to client-side apps using REST and JSON. They could use other formats. They could not use REST. They could use different requests. They could use not JSON but XML or other kind of data formats. But that's the main architecture decisions. Okay. So it was created in 2010. So it's not so new. It's kind of popping out today because of big guys in the past already use it, like Airbnb, BitTorrent, as I said, Trello, Walmart, WordPress, Foursquare, Pinterest, and now Macy's and Bloomingdale's. So this is kind of mature already because many people are using this. So they found out problems. They improved the quality of the library. We have new very good other frameworks today, like AngularJS, like Ember, like Knockout. They are other related frameworks, but Backbone was the first one that was used by big guys. It depends on _JS. There's another talk about this later. _JS is a kind of utils library with great functions to manipulate data, arrays, strings, collections, and jQuery. We could also use like Zepto.js, which is similar to jQuery with varying degrees of compatibility. If you want to use Backbone on mobile, you can use Zepto. Okay. So what is this about? This is the most important part of our talk at this moment. SPA. What is SPA? SPA is a new concept. Single page application. Is an architectural style about doing a single page load the whole application. So the idea is you load a page, you load a site. The first load is the same as the old frameworks like Rails, not old, the classic frameworks like Rails and Struts. It will go to the server side because you have nothing else yet, and we'll bring the response. But as we bring the response, we don't bring one page, we bring an application. And this application will structure and load the rest of the page. So starting from the point you have this application loaded and running, you go and you are already controlling your application JavaScript now. So the next phases, the next interactions, your JavaScript can take care of this. So this is why we call single page application. We load one page with all the application. Okay? Then we can route, we can go to new services, you can get data, you can save, you can do everything that you do in web applications from the same state, which means you don't have to reload unless you want. Okay? So it's common to see, like, if you implement this in Rails, you just have one controller, just to give one view, one single view. If you do this in Struts, it's like that. You just have one view for the whole thing, because everything else is coded in JavaScript. Well, which are the elements of Backbone.js? Model, collection, view, and router. It's very easy. They work very well together. So my purpose here is just to introduce you to those four elements, and then you're gonna learn that you can build any Backbone application with those guys. Okay? Backbone.js is not a classic MVC framework. Okay? Why? Because you don't have controller. Okay, we have collection. Model, collection, but collection is just a superset of models. We have view and router. Why? It's because Backbone was designed this way. It was designed for the model to be supplied to a view. And that's it. But we say that Backbone belongs to the MV whatever MV whatever family, which has similar goals. The idea is the same, to structure the application into model, view, and something. But it doesn't matter much if you have a controller. Like, I think Angular, you can confirm me, Ciro. I think AngularJS is a correct MVC, right?
Yeah.
It has a controller. Backbone doesn't have a controller, but it works the same. It can achieve the same goals. And we have, I think we have Knockout.js, which is not also, it's not MVC, it's MVVP. It's another platform similar to this. Is another pattern, which is not MVC, but it also belongs to the MV whatever family. So what I say here is that we consider all those frameworks as MVC or MV whatever, but it doesn't matter. It doesn't have one element or another element because they are there to solve this structure problem. Okay? All right. So let's understand what is a model, a collection, a view, and a router. Okay? Model. Model will just store and manipulate data. It would communicate with REST APIs. It supports parsing, translation, validation, and business logic processing. This is a simple model. This is JavaScript code. So I'm creating a var called card model. This is just a boilerplate method, like we have to use this to create an object, Backbone model extend. And we pass an object here. We pass one attribute, URL root /API/cards. If we say that, we are teaching the model how to work with a REST server. So if it will use /API/cards as the prefix for every operation. How does it work? Here, there is a fetch, so I'm going to explain you through these methods. Given that we have a URL root defined, we can call fetch, which will retrieve an entity via HTTP GET. So in this case, if I call fetch on the model, is a function, it will go to /API/cards and we'll do a get on there, and it will retrieve data from this URL. Okay? If I want to save, it will call HTTP method post or put, depending if you have a new or a already existing entity, to /API/cards. That's the idea. So which are the methods? Fetch will retrieve using get. Save will create an entity using post or put. Post is to create. It will look for the ID. If the object has an ID, it means the object exists and I'm giving an update. So it will use put. Otherwise, if it doesn't have an ID, it will understand it's a new object. So I'm going to use post. And destroy. If I call destroy, it will remove the entity using delete. So it's easy. This is the model. The model is translating a REST API to an object. And you have functions. So if you call fetch in the model, it will go use the REST API and do a get method, and etc. That's the idea of model. Okay? With this data that you have, you can transform, you can have methods, functions to parse and do anything you want. There are some parameters from this, like every operation of fetch, save, and destroy will go to the client, to the server side. So we have success callback and error callback. Okay? These can always happen. So for all of them, we can have Options, in these options, maybe sometimes only to get you want to pass another URL, so you can pass another URL just for this operation, and you pass two handlers, success and error. It's a callback function. So how do we work today? We have a model. We call fetch. If the data comes, it will hit the success function handler. And inside this function, we get this model and send to a view. And the view will render for you. So that's the normal way, the usual way to use routes in Backbone. This is an example. We have a var model. We are instantiating a card model because we defined the card model. It's like a class. I'm going back here. Okay, here we are defining the card model as the model. So this is a kind of a definition of a class. Card model with uppercase C. Now we're gonna use this. We are going to instantiate this card model using new, and I am passing the ID equals 1. This could come from the URL. And then this is a get to /API/cards1. So I'm going to do a fetch. If I do a fetch, it will call /API/cards, and it will append the ID 1. So I'm going to call, if I do model.fetch, it will do this get. And I can pass a success handler and an error handler. This is just a function that will print to the console, success or error. Just that. Okay? Model has other methods. I'm not going to cover this right now with you. Otherwise, this presentation can be too heavy. But it's here on the slides for you to verify later. Like get, if you want to get an attribute for a model. Set, if you want to set. To JSON, if you want to convert the object to a JSON. So you can check it out later with more calm, those functions. And we have many other functions as well. Right, so this is the model. We only have 3 more guys: collections, views, and routers. Collection. Collection is just an ordered list of models. Just that. So sometimes you want to retrieve lots of models in a single call. So this call is not an object, it's an array. So then you pass this not to a model, but to a collection. The collection will identify that this is an array, and it will instantiate properly. It also implements array methods from underscore, which are very handy. And in order to create a collection, you need to specify one model that this collection is about. So if you program in Java, you can think that the model is your entity, and this is just the list of that model. Just that. So when I do card collection, I'm going to pass the model, which is the definition of the model, card model, and the URL, /API/cards. So if I do a fetch in the collection, it will hit this URL. And if I receive an array with many cards, it will create inside lots of models. It will instantiate. If I have an array with 10 objects, it will instantiate inside 10 models, inside and organize in the collection. Only that. So the collections were created to extend the API, the REST API from the models. For instance, if I do the fetch, as I said, it will retrieve an array of entities via get, populate each entity as a model, and insert this in the collection. Like this. I instantiate the card collection. This is exactly like using a model. You have the fetch method, you pass a success handler and an error handler. Okay? That's it, collection. There are some methods. Get. So this you can get from the collection. You can get a model from ID. So you get the model that has the ID 12. You have the add that you're going to retrieve by the position of the array. Okay? The element at the position 1. Add. You can also add mod. You can do other calls and add more models to the collection. You can remove. It's just like a list, a linked list. Okay? And to JSON, you transform to JSON. And there are 2 methods that I like very much. It's amazing. And they are from underscore. Where? Where you can kind of do a SQL. You can do a where query in the collection. So if you pass, I want you to return me all the models which type is project, which has the attribute type with the value project. It will return to you just the elements that have type equals project. This is very nice. Think about how to do this in Java. You need to do a for, inside the for you need to do a if the type is private, right? Yes, this should be a column. Thank you, Felipe. This comma should be a column. Yes, I didn't run the code from my from this. Pluck. Pluck returns. Pluck is like the select. If you think in the SQL, is the select part. This is the where, pluck is select. So I have a collection that every model has lots of attributes. I just want the title of each element. So I do collection.pluck title. So I'm going to receive an array only with the titles of each model. And this is very fast. So it's very nice. Okay, we are done with collections. So now let's go to view and router. And then we are done. Oh, there is the templates too. So the view. The view will manage presentation logic and events. By the way, there are some people that consider the view as the controller. They think actually the presenter. Some people believe that Backbone.js is MVP, is Model View Presenter. And some people understand that the view is the presenter. The presenter is a kind of mixed concept. If you mix controller and view in one thing, it's like the guy that controls events and controls what will go to the user, the data that is going to the view. So, but this is just interpretation. Backbone.js does not officially say I am MVP, but many people can look to the view and understand this as a presenter. It manages the presentation logic. It will render an HTML template which can be added to the DOM, consuming data from models or collections. So you have data, you go to the server, you have models or collections, go to the server, bring data, you pass this to the view. The view will automatically process this data and render this in HTML, and also add to the page, to the DOM. So it is going to do all the dirty work for you. The HTML template can be dynamically generated, which we're going to talk later. There are many frameworks that can generate HTML. If you give data, they can just give you a string with an output. But let's skip that for now. Let's talk just about the view. View has some attributes to be implemented. Every view, you can have an event object, which is an event mapping object, like this. You have a CSS selector, and you pass a function. A CSS selector, and there should be an action here. I forgot to add here. I'm going to show an example. But you have a render object, and you can specify every action that your elements can receive. This way, you bind all your events since the beginning, and it's a more clear way to program your events. And you have the render. The render method is very important. It's the method that's going to do all the work for you. It has 3 steps. First, you prepare the HTML template or retrieve. It can usually is a function, okay, that you're going to give data, and it will output string. Then it will render the HTML template from the model or collection, and after it renders, it will insert into an attribute called EL. EL is just an attribute from the view that with this EL you can insert to the DOM. Okay? It's a placeholder for the generated content from the view. Let me give some examples because this part is the trickiest. Okay, here. Here I'm creating a card view. This is the event object. I'm saying that if I say click is the event on a button that has a class close. So this is a CSS selector. It's the same thing if I go jQuery, gets the button closed, and I use the function click to program, oh, when I click to this button, do this following. So here I'm saying, if the user clicks on the button with classes closed, there is a function that will prevent default and remove. Okay? That's the event. Render. This is the render. So let's suppose the model has a title, has a data, just one attribute, title. So here I create a template, a result. It has one tag h1. I put here the title, and I close the h1. And I also append that button that has the class closed, fechar. I have this result. So this result is done. This is a string. I have the string of what I want to put in the page. By having this, I will use this dot $EL, which is the internal element, and I will set the HTML of the element as the result. If I do that, I have the view is ready. The view render, after I call the render function, the view render, and I have the EL attribute ready to be inserted to the DOM. And the user of this class, of this file, the view, the guy that uses the view can use the EL and insert wherever he wants. I'm going to show it here. This is an example from the model. I have a model. I create a card model with the ID equals to 1. Then I call the fetch. It goes to the server side, gets one card that has the ID equals 1. In the success, I create a card view. When I instantiate the card view, I need to pass the model. Which model I am going to render. And then I just call render. The render goes inside, because if you remember, I go back here, inside the view, it has a model. It will call the model.getTitle. So I call the render, it comes here, gets the title, put into this string result, and appends to the HTML of this element, EL. So now, after I call the render, the card view has EL ready. So what I'm going to do, I'm going to insert to my div contents, I'm going to append the EL of this card view. This is the usual way we use. We have a model or collection, we fetch. In the success handler, we create a view from this model that has data. We render. After we render, we have the EL element ready, which we just insert in this. Okay? That's the basics of Backbone. There are some functions that I didn't cover. Like we could have EL, model, or collection. Actually, I covered. Okay, guys, that's the view. So it's not complex. If you compare this to how you program a Rails application or a Spring, you're going to see this is much easier. The concept. You have a collection or a model that goes to the server side and renders a view. But the construction in JavaScript might look a little bit complex, but after you use a little bit, you're going to see the concept is very clear, so it's easy to program this way. Last part is router. So we have this flow, model or controller, model or collection to view. What is a router doing here? The router allows for URL handling and routing. And it also controls the navigation history and avoid direct requests to the server side. The idea is we have a request. You do a request, it will intercept the request. Instead of going to the server side, it will hold, and the router will call some model to go to the server side to do some data thing, retrieve a response, and send to some view. Send it to some view. That's the idea. The router has just one attribute that we care about, routes. So do you remember the events object for the view? It's like the same thing. We're going to specify URIs and functions. So if the person hits /novo arquivo, new file, new card. The router will call the model to create a new card and call the view for you. So the router is the guy, is the front controller, if you think like that. If you compare to JSP, is in Spring MVC is the front controller. The router has some common methods, like instead of adding through this attribute routes, we could add routes through methods. And here we can use regular expressions. Like this is kind of ugly, but if you do this card, I'm passing here that it will only accept digits. So if I pass an ID that has strings, it will not accept. So this is safer than putting anything. Navigate is maybe you are somewhere in your application and you want to bring the user to another route. So you can call navigate to the route card 32. If I pass trigger equals true, it will trigger the route. If I don't pass, it will only change the URL. So we use this to navigate internally in Backbone. Okay.
It uses push state.
Push state, yes. The push state of HTML5, I don't know if I think I didn't mention here. The push state is the approach, because if the browser accepts push state, it will handle for you. If it doesn't use push state, the router will implement using the hash sign in the end of the URL. It's kind of going to fake this behavior. This is an example. So app router, we have the routes object. I'm defining 3 routes here. Blank is view all. If I just go to my site www.avenuecode.com, it goes to view all. If I do /card and I pass an ID, this is an attribute ID of the card, I call the function view card. And here, the function view card receives this ID here that we can send to a model to go to the view and render and etc. And there is this exception. If I do anything else and pass, like I didn't need this pass, I could do just this. If I do this, view all. So if anything else, view all. Okay? It's necessary to call Backbone history start before you use a router, so that the router will start monitoring the route. And this is, if you pass push state true, it's going to use push state of HTML5. Otherwise, it's going to use the hash sign after the query string, as I said. So all you need to do is instantiate the app router, and then you call Backbone history start push state true. You see that this call didn't invoke this app router, because it's going to do for every router that got instantiated in this function. Okay, so we covered it. Models, collections, not controller, and views, and routers. That's it. Dynamic templates, what is this? So, it's hard to create templates in the views, in strings. It's not a good idea, like we did. Let me return to the view example. Imagine you want to do this for every big HTML file. This is not good. This is like servlets did before they created JSP. So people started to use template generators. So in HTML, actually in JavaScript, you're going to use JavaScript libraries, and you can program a template that's going to be a JavaScript function. So you just pass data to the function will give you HTML already processed. And this will go to some server, like actually you have the data from some server. Let's suppose you have the model, you brought JSON. You just give this data to the template, and the template can be defined in some other language. So next week there's going to be a talk about handlebars, which is one good approach. And handlebars has a language for that, which is very easy, very expressive, so you can read data. So I'm going to show an example here. There are many others, like underscore, mustache, dust.js. It's the same idea of PHP, JSP, ERB, ASP, but now on the client side. Like, much more maintainable than concatenated strings. So, handlebars, I'm just quickly saying it. It's a performative, flexible, and easy to learn and to handle alternative. This is an example. The tags are double keys, actually, not curly braces. It's double curly braces. So there is, if there is a JSON attribute called children, I run this. Else, I just put HTML, no items. UL. So I can do a each. I can create a UL, and for each children that I have, it's like a for, it's like a for each. I'm gonna create a LI, and I'm gonna read from the JSON, from the children, title and description. So this way I can program one list from JSON that has an array of children. Okay? It's easy to understand and it's easy to program with HTML. Alright, conclusion. Client-side apps aim to reproduce the desktop experience on the web. Client-side apps can drastically reduce the waiting time by the user for feedback, because you are no longer waiting for the browser to bring you the information. You are now waiting for the library, the JavaScript to bring you the information. Then you can do, you have freedom to do other information, other navigations. Hence, the chances for the user to stay on the system are greatly increasing. Let's suppose you are in an e-commerce system. If the system takes much less time to respond to you, it's better. Sometimes the user can get tired of be waiting for pages and leave. Backbone.js is a mature. I'm not saying it's the best, because it has problems. I'm not saying it's the most used, because I don't know. But it's a mature because we know we have big guys using, and it's properly designed to get big demand. So it's an MV whatever alternative to structure client-side applications. Learn more. So I'm giving here some links, and if you go later to the bootcamp page in Avenue Code GitHub, you can find it there as well, like this presentation too. The official website, backbone.js.org. This is a very good book, free, like you can read it free on the internet, or we can buy, from Adi Osmani. This guy works on Google today, and this guy is a very good guy about JavaScript. This is a book that he wrote about Backbone. This book even teaches how to test, how to use Jasmine, and how to do the full cycle of development using Backbone. It's very cool. The Anatomy of Backbone.js, this is a course in Code School. We have here in Avenue Code access to Code School, so if you don't have yet, you can talk to Renan and apply. Maybe the next batch of people you can get access. You can do the course. This course is very nice, it's very interesting, and you can learn better and do some exercise. And there is a challenge. So I would like to propose to you all to make a challenge. And this challenge is for you to exercise Backbone.js. This is going to make you feel more how to use this. And I would like you guys to do in your personal GitHub account, so you can create, if you don't have, it's free. You can create a public repository, create any application, and just share with me. Okay? This is the challenge. Write a multiple choice quiz about a subject of your preference as a client-side application using Backbone.js. So a quiz. You just need to present some questions, and the user needs to vote. After he votes, you present him with another question, and so on. And after, we're going to see the results. Okay, so which are the steps? 1, the username and email should be collected in the beginning. There should be 5 possible answers per question. Okay? A, B, C, D, E. You can have either just 1 or up to 3 answers per time. So for every question, you can have just 1 correct answer, or maybe 1, 2, or 3. So you should allow the user to select just 1 or select multiple answers up to 3. At least 5 questions on the quiz. You need to do at least 5 questions. Lastly, the user must see a graph of all the questions and answers from all users with percentage for each answer. So we need to collect the answers and later show to the user a graph for the percentage for each answer. Let's say, there were 5 questions, so you answered 40% of your answers were A, 20% of your answers were B, okay? And you should use any approach for persistence, as long as it uses modules. So you can create a REST backend, you can create a database, or you can use local storage on the browser, or you can use a session object, you can use a cookie, you can use a local file, you can fake. Maybe you don't need to do anything, you can print to the console, I don't know. You can put in a var, but you have to use the model, okay? So this is the challenge.